In this video, we're going to look to find the center of mass of the curve y equals sine of pi x from x equals 0 to x equals 2 and y equals 0, are the bounds. Now, here's our formulas for x bar and y bar. And now this is when we're doing between two curves. Well, we can think of that 0 as our g of x, which will zero out that in all of these equations, making them a little bit simpler. So let's see how these are set up, and then I'll leave the calculating the integrals to you guys. So first one, the total mass is going to be the integral from a to b of rho of x times just f of x dx, because think of what this does. This, with f of x and g of x gone, this gets the area under f of x between a and b. Multiplying it by the density gives the total mass. I've already set up this integral here, the integral from 0 to 2. We're just going to do a constant density for this problem, but if the density did depend on x, it would just go right here in our integrand. And then we're doing the area under this curve, dx. If you calculate this, you should get 2. Now, next thing we need is our m sub y. Now notice that the m sub y is actually for our x bar. I know that notation can be a little bit confusing, but it's the tendency to revolve around the y-axis is why we use m sub y. So m sub y is pretty easy to do because it's exactly like m, except there's an extra x in there. So I'll have 0 to 2, rho times x times sine of pi x plus 1 dx, and that's equal to 2 minus 2 over pi. Again, leaving the calculation to you. What you would do is you could pull out the rho, and both these should be getting multiplied by rho, excuse me. Pull out the rho, distribute the x. This first part will need integration by parts. This second part will just be the antiderivative of x. That's where the 2 came from. You should be able to finish that off. Last one, m sub x. Once we have this, we'll have all the pieces we need to get x bar and y bar. M sub x is basically, if you want to see where this formula comes from, that's in another video. It's this guy with this part removed. So I'm going to write it as 0 to 2 rho over 2. So I'm putting the 1/2 in the integral for right now, just because of the way I want to write it. Sine of pi x plus 1 squared dx. Now, when you go to calculate this, what you're going to get is actually a nice number. You'll get 3/2 rho. So we now have all the pieces to find x bar and y bar. It's just a matter of putting them together. X bar is m sub y over m, which is 2 minus 2 over pi rho over 2 rho. Whenever there's a constant density, the rho will always cancel out. In other words, the center of mass does not depend on the density, just the shape of the region. If you want, we could simplify this to 1 minus 1 over pi. Y bar is m sub x over m. So 3/2 rho over 2 rho. The rho's against cancel, and we get 3/4. So there are the coordinates of the center of mass for this particular region.